Welcome to the introduction to Tesla Model S Autopilot. Tesla's Autopilot, as of early 2026, is an advanced driver assistance system at SAE Level 2. It assists with steering, acceleration, and braking, but requires your constant supervision. This video will guide you on how to enable, activate, adjust, and use Autopilot safely on your Model S. Before activating Autopilot on your Tesla Model S, ensure your vehicle has the latest software update. This should be version 12.5.x or newer, which you can download through the Tesla mobile app or via in-car Wi-Fi connection. Next, meet the basic prerequisites for using Autopilot. Your Model S must be in drive mode with all seatbelts properly fastened. Additionally, certain model years include eye tracking technology that requires confirmation of driver alertness before activation. Finally, verify that Autopilot is enabled in your vehicle's settings. Navigate to the Controls menu, then select Autopilot to ensure the feature is activated and ready for use. To activate Autopilot, first engage cruise control by setting a desired speed above 18 miles per hour using the right steering wheel stalk. Once cruise control is set, pull the right stalk towards you twice quickly. This activates auto steer, centering the car in the lane and maintaining the set speed. The Autopilot icon on the display will turn blue when active. Customize Autopilot settings via the touchscreen under Controls, Autopilot. Adjust speed limits, lane changing aggressiveness, and following distance. For cautious driving, set to conservative mode. Familiarize yourself with each setting to optimize Autopilot for your driving style and environment. Regularly update your software to incorporate the latest safety patches. Autopilot's effectiveness relies on sensor fusion, combining inputs from 8 surround cameras that provide 360-degree visual awareness, 1 forward-facing radar for detecting objects and speeds, 12 ultrasonic sensors for close-range detection, and an internal inertial measurement unit that tracks the vehicle's movement and orientation. These sensors enable advanced features like collision avoidance and adaptive cruise control. Cameras handle lane keeping and traffic sign recognition, while radar and ultrasonic systems provide precise distance measurements for braking and parking assistance. All this sensor data feeds into a sophisticated neural network that processes the environment in real time, using machine learning algorithms trained on extensive driving data to make driving decisions. While this AI system is highly advanced and continuously improves through over-the-air updates, it's crucial to understand that it can still make errors in complex or unexpected situations. Driver vigilance remains essential, as the system requires constant supervision and readiness to intervene. Autopilot's safety mechanisms are designed to ensure constant driver engagement. Driver-facing cameras monitor your attentiveness, detecting if you're looking away from the road or not paying attention. If your hands are off the wheel for more than 1 minute, the system will first issue audible alerts to get your attention. If you don't respond, Autopilot will automatically disengage, requiring you to take control. Remember, you must always keep both hands on the wheel and be prepared to take over driving within 2 seconds. The system uses eye tracking on supported models to verify your focus. To ensure safety, avoid using Autopilot in adverse weather conditions like fog or heavy rain, or in unfamiliar areas where road conditions might be unpredictable. Always prioritize your engagement with the driving task. Autopilot has shown significant benefits in real-world applications. A comprehensive 2025 NHTSA study analyzing 1 million miles of Autopilot data revealed a 35% reduction in rear-end collisions compared to traditional human driving. In Tesla's monitored fleets, there were 0 fatalities during this period. Despite these successes, incidents underscore the critical need for driver supervision. In June 2025, a Tesla Model S operating on Autopilot collided with a stopped fire truck on a California freeway. The investigation determined the driver was asleep, violating Autopilot's supervision requirements. Sensor occlusion caused by fog was also a contributing factor, prompting Tesla to release a software update for improved weather detection. In urban environments, such as Tesla's 2026 pilot program in San Francisco, Autopilot demonstrated a 50% reduction in lane violations during dense traffic conditions. However, challenges persist, including instances of incorrect yielding at crosswalks, which highlight the ongoing refinement needed for complex scenarios. These examples illustrate both the potential and limitations of autopilot technology. Always remember that autopilot is an advanced driver assistance system, not a replacement for human driving. Drivers must remain alert and prepared to intervene at all times to ensure safety. Experts from organizations like ENFSA emphasize that autopilot saves lives when used correctly, but can amplify risks from driver disengagement. Tesla CEO Elon Musk argues it's statistically safer than human drivers, while safety advocates warn of complacency risks. Statistics from 2025 show autopilot-enabled vehicles have a 0.23 crashes per million miles rate compared to 1.2 for human drivers, but only when drivers intervene promptly. NHTSA reports 18 fatalities since 2016, mostly due to misuse. Looking ahead, trends point towards stricter regulatory oversight with the EU's AI Act and US uniform standards. Tesla aims for level 4-5 autonomy by 2027-2029, integrating V2X communication, but cybersecurity and ethical AI biases remain challenges.